Functional programming. Let's talk about it. As the name suggests, functional programming is all about using functions to get a specific task done. Lua is already a functional language, right? We have the ability to create functions. We have the ability to, let's say, pass a function to another function. So if I called my function and I wanted to pass another function to it, I could do that. We also have the ability to return functions from functions. So let's say my something function returned another function. I would be able to grab that when I called the function. We have the ability in functional programming for a function to call itself. I can call something within something. This is recursion. We even have the ability to call a function within the call of another function. So maybe something needs to return something. I can call it within the call, get that return value, and pass it to my other call of something. These are most of the basics you need for functional programming. When it comes to Roblox Studio, you use functional programming all of the time. Even if you use idiomatic object-oriented programming, you're still using elements of functional programming because Lua is a functional language. But we will discuss a few principles in functional programming and how we can share, let's say, functions between multiple different scripts. So one of the main principles in functional programming is this idea of pure and impure functions. Now, a pure function is one that does not need to rely on any external data to get a task done. The same inputs should always result in the same output from a function. It doesn't cause any side effects. It doesn't use any data that's outside of the scope of the function. Everything is handled within the function, and the same inputs give the same outputs. That is known as a pure function. And the great thing about pure functions is that because the same inputs result in the same output, they're basically modular. So you can take those functions, put them in something like a module script, and use them for multiple different scripts because that function doesn't rely on any external data. For example here, let's say this something function took an input of A, B, and C, and what we would like to return is A plus B plus C. This is a pure function. It doesn't rely on any external data, and the same inputs of A, B, and C will also result in the exact same output every single time. This is a pure and modular function. Now let me show you an example of a function that would not be pure, an impure function. Let's say we had some kind of variable outside of the scope of this function. I'll just call this, I don't know, my string. And let's say it's a string of hello. And let's say this function relied on that variable. And let's say this returned something like my string concatenated with A. Let's just pretend A is a string. This is an impure function because it's relying on a variable or a value that's outside of its scope. This is impure. And an issue with this is that the same input might not always result in the same output. What if another piece of code manipulated my string and set it to a different string during runtime? Like maybe it changed from hello to hi. Well, even if we pass the same input, we're going to get a different output, and that's because my function is relying on this external piece of data. This is an impure function. Now, one of the issues with impure functions is that they can be unpredictable, and that's not something we typically want in our code. We want our functions to be predictable and produce consistent results, which is why, if you're going to practice functional programming, you need to make sure that your functions are pure. So let's have an example of using functional programming. For example, I have this table right here containing other tables that basically represent animals. Like I have a dog, a spider, a fish, and they have a leg count and an eye count. Now let's say we wanted to be able to filter out specific animals from this array. Maybe we only want all of the animals that have 2 or more legs. So one way typically we would think about doing this is we would create a table. Let's just call it something like animals with 2 legs or more. So this is our table. And then we would usually just loop through all of the animals inside of our animals array. And then we could do a check, like we could check if the animal's leg count, if that's greater than or equal to 2, then we'll insert this particular animal into our animals with 2 legs or more table. And then when we go and print out our animals with 2 legs or more table, and when we run this code, our table should be filled with all of the animals that have 2 or more legs. So we get our bird, we get our spider, and we get our dog, and our fish that has no legs was omitted. This is one way we could, approach this issue. But what if we wanted to approach this in a functional manner? Well, what we could do is we could have a function, we could call it like filter, and we could give it another function, and the purpose of that other function we give to it is to filter out specific things from a particular array. So let's create a function up here. Let's call it filter. And we want to give this filter function an array of items, and then we want to give it a function to tell us when a particular item should be filtered out or should be included in the result that we want to return from this filter function. Now, usually what we would call this function is a predicate, and a predicate's just a fancy name for a function that returns a Boolean. So we need to pass a function to our filter function, and the purpose of this function is to take an input and return a Boolean output. So now what we can do with an array that we're given is that we can loop through every single object in that array, and then this is where we would use our predicate function. So we would call our predicate function and pass this particular value or this object in our array. This function will do the work to determine whether or not we should include it, and if we should, then we should insert it into like a result table. So we could do table.insert into our result, this particular object, and then at the end of our function, we'll return all of the results. So instead of doing it this way, instead, we could create our animals with 2 legs or more table, and that's going to be equal to the result from our filter function. So the array that we need to filter through is going to be our animals table, and the predicate needs to be a function, and our function gets passed a value, and that value is going to be a value that's inside of this array that we passed. So this is going to be our animal, and here is where we can return to check to see if this particular animal has 2 legs or more. So we can return the animal dot leg count if that's greater than or equal to 2. So now if we run this code, we're going to get the same result. We'll have a table containing all of the animals that have 2 or more legs. And this is a functional approach with this issue. This filter function is pure, and it's pure because it doesn't rely on any external data, and the same inputs will always result in the same outputs. So even if I were to run this code a whole bunch of different times, because I kept the inputs the same, we always got, what do you see? The same output. We always got the same animals every single time. Now, the awesome thing about these pure functions is that they're modular. We could pass any array here, and then we would pass a function to filter out specific stuff from that array with any type of table that we want. So this is where we create a module script, and I'll title this module script filter because it's going to store my filter function. And instead of returning a table, which is lame, we want to return a function, and this is going to be our filter function. So we could literally just copy all of this code, paste it here. This function needs to be passed an array and a predicate, and there we go. Now we can require this module script from any other script in our game and use this function. So instead of having to declare a filter function here, instead I can create a variable called filter, and we'll set it equal to, and we'll require from game get service server script service, and we're going to grab our filter module script. Boom, now we have access to our filter function. So if I run the code and I execute it, what are you going to notice? Well, it worked, and we got the exact same result once again. Now, one minor issue you might notice with this method is that if I were to refer to my animal that gets passed to my predicate function here, the Lua interpreter doesn't know what this is. It says error type, and because it's an error type, we can't autofill any of the information. We can't access the name, the leg count, the eye count, etc. So one way we could fix this is by converting our filter function into something called a generic function, which means that we declare a type for the function, and that type has to be passed somewhere within the parameters of the function, and that allows the Lua linter to autofill information because it's going to know what the type is. So it's going to know that this is an animal. This dives into more type annotation territory. And if you're not familiar with type annotation, I'm not going to explain it right now because that's just a whole bunch of other stuff for later. But I'm going to convert this function to be generic by declaring a type that it takes. We call it type T. And our array here needs to be a table that just contains a bunch of these particular objects of this type. And then our predicate needs to be a function. So we declare that with our parentheses, and we tell it that it needs to return a Boolean. And the input to this function is going to be our type T. So now we have created a generic function, and this means the linter, when we're autofilling, is now going to know what an animal is. You see, now it knows that this is an animal because we've declared that type up here. So I can index it, and boom, we can see the name, the leg count, and the eye count, and that's because we made our filter function a generic function. So now that we have a list of, let's say, animals with 2 legs or more, let's say we only want the names of the animals. So instead of storing a table that contains all of the information for each animal, maybe we just want an array of objects that just give us the names of the animal. So another way we could do this is by creating another generic function that takes an input, an array, and we are able to map the value. So basically we take an input and then we give a different value output. And these are typically called a map or a mapping function. And I'll show you what I mean. So let me create a function here, and I'm going to call it map. And the purpose of this function is to take another array, and then we need to pass it another function. Typically it's called the mapping function. And the purpose of this mapping function is to take a value that is stored in this array and give a different value. In this case, we want to give our mapping function our animal, which contains the name, the leg count, and the eye count. And we want our mapping function simply to just return, let's say, the name of the animal. So what we would do in here is we would create another result table, and we would loop through every single object that is inside of this array, and we also need the index of that as well. So for every single object at a current index in our array, what we need to do is we need to set inside of our result table at that exact same index, because we want to be consistent. We want to set it equal to whatever value is returned from our mapping function. And we need to call this function and pass this particular value to it. And then at the end of our mapping function, we can return this result. Now, again, I'm going to make this a generic function. I'm going to declare a type, let's say T, and our array needs to be a table containing those objects of type T. And then our mapping function needs to be a function that takes an input of T of this particular type, and this needs to return whatever value. We don't know what that value is going to be, so we could denote it as any. We could say it's going to return any kind of value. Or another way we could do it is we could declare another type for this function. We could call it type like K, and we'll say this function returns that particular type right there, type K. We don't know what K is. This is why it's a generic function. These are just placeholder names for the types. But now let's say we want to get all of the names of those animals that have 2 or more legs. So this is where we would call our map function. We would pass our array, which is our animals with 2 legs or more. And you see now it's already autofilling for us. It knows that this is going to be an array full of animals and that our mapping function is going to be passed one of those animals. So now we can create a function here. We're going to be passed an animal. And what we want to do is we want to be able to return a different value based on this animal right here. In this case, we want to get the name. So we could just return our animal dot name. So now if we print out the names of this animal, we should just get a table full of names. So there we go. At the first index, we got dog. At the second, we got spider. And at the third, we got bird. And if we look at our original table that contains all of those different animals, you'll see that at the first index, we had a dog. At the second index, we had a spider. And at the third index, we had a bird. So it stayed consistent at keeping those objects at the exact same index as in the original array that we got from our filter function. Now, what's the other great thing about this map function? Well, this map function is also a pure function, which means we can make it modular. We can put it in another module script and use it from any script in our game. So we can literally just delete this or copy it and then create another new module script. And this will be called map because it's going to be storing our map function. And all we need to do is return this particular function. So let me get rid of that. And then we don't need the identifier here because we're directly returning this function. So we'll do that, and boom, now we have our mapping function. So instead of needing to create it inside of our script and not being able to share it between multiple scripts, it's now inside of our map module script, and we can just require it. So we'll call it map, and we'll require from game get service, server script service, and we'll grab our map function, boom. And if we were to call our map function, there it shows us that we pass it an array and that we need to pass it a mapping function that takes an input of that type A and returns a type of B, whatever that type is. And if we go and execute our code, look at that, it still works, and we still get an array of dog, spider, and bird. This gives you a whole lot of options on how you want to filter out stuff inside of your arrays. So for example, instead of filtering out by the leg count of our animal, maybe instead we want to filter out by the eye count of our animal. So this time we want to make sure that the eye count is, let's say, greater than or equal to 8, which means we should only get a spider. So if we run this code, we got one animal, and look at that. It was our spider because the spider was the only animal inside of our animals table that had 8 or more eyes. This is kind of the beautiful thing about functional programming, is that you have these pure functions that can take inputs from anywhere, and it will always return the same output if you give it the same inputs. Before I end this video, I just want to give you a couple more terms in the functional programming world. So we know that a function, let's say, we'll call this test. If it returns a Boolean, we would call this function a predicate. So any functions that return a Boolean is a predicate. Now, another thing we want to talk about is something called higher order functions. And a higher order function is basically a function that takes another function as an argument, or maybe it returns a function. So with this other function, let's say this other function needs to take in a function, I don't know, I'll just call it A, and this function needs to return, I don't know, some kind of value, whatever. If a function needs to take a function as an input, or let's say a function returns another function, that would be considered a higher order function. So our map function and our filter function would be considered a higher order function because they take functions as an input. Now, another thing I want to go ahead and touch on is recursion. So in pure functional programming, there is no such thing as a for loop. Instead, you use functions to loop through specific things. So let me actually demonstrate that for you. Let's say I had a function, I'll just call it iterate. This is going to be my iterating function, and it needs to take an array to iterate through. So this is going to be my array. It'll just be, we'll make this a generic function too. So it'll be an array of whatever type. And we also need to be able to keep track of what current index we're at while we're looping through this array. So we also need to pass a number to this function, which declares the current index that we're at. And then another thing I want to do with this iterate function is I want to give myself the ability to do whatever I want with a specific value. So let's say we had another function, I don't know, I'll just call it A, just for demonstration purposes. And this is a function that takes the input of t, and it might return something or it might not return anything. So I put a question mark here to say this function might or might not return anything. But what we'll do here is we'll get our current index and we'll grab the value that is stored inside of our array at that particular index. And then we can call our function and pass that value to it. So that gives us the ability to do whatever we want with that particular value. And then once we're done doing that, we need to move on to the next iteration or the next object inside of our array. So in order to do that, we just need to call our iterate function from within inside of itself. This is called recursion. And we just need to pass back the same value. So we pass our array, we pass our function, and this time we need to increment our index. So we'll pass our index plus 1. Now, one more thing we need to do is we need to make sure that we don't iterate through this table more than its size. So let's say there's 3 elements in our array, if we don't add a check to see what index we're at currently, this will just keep going and going and going, and our values will just end up being nil because let's say we go to the index of 4. Well, our array only has 3 elements inside of it, so there's not going to be anything at the 4th index. And then if we go to the 5th index, there's nothing going to be there either. So we need to give us an ability with this iterate function to break out of it. Because right now, it's just acting as an infinite loop. There's nothing stopping this function from just repeating on forever and ever. So instead, what we should do is we should have an if statement to check to see if this current index, let's say it's equal to the max amount of elements inside of our array. So let's say it's equal to the length of our array. If that is the case, then we don't want to execute any more code. But let me actually fix this up a little bit. Instead of saying it's equal to the length of the array, we'll just check to make sure that it's less than the length of the array. Okay, so now what we can do is we can call our iterate function. We'll pass it our array of animals. And what I would like to do through every single iteration or grabbing every single element inside of our animals table is I want to, let's just say, print its name out into the console. So we'll be able to get that animal, and let's just print out the animal's name. So we'll print out animal's name, and then finally we're going to have to give it an index, and we're going to start at the index of 1. Okay, now let's run this code, and there we go. We get our dog, then our spider, then our fish, and then our bird. And then because we get to the point where our index has become equal to the amount of elements in the array, it doesn't call the function again, and instead reaches the end of our function and it just returns and does nothing else. So we were able to break out of that iteration loop. So this is how looping is done in functional programming. There is no for loops in pure functional programming. Instead, you use recursion and just have a function call itself. You know what's the other great thing about this iterate function? Well, it's also a pure function. The same inputs should also result in the same outputs, which means I can migrate this function to another module script like we did with the other ones. Now, I really only touched the surface of functional programming. There's a whole lot of other principles and ideas of functional programming that I'm not going to dive into, but I hope this gives you a very good introduction or understanding of functional programming compared to, let's say, object-oriented programming. Now, Lua is a functional programming language, so you already use some of these principles or ideas of functional programming every single time that you code in Roblox Studio. Now, what is my opinion on functional programming? Well, it has its uses. And whether you want to use functional programming or you want to use object-oriented programming, it doesn't really matter to me. Use what you're most comfortable with. For me, object-oriented programming is easy to read, and I like this idea of being able to encapsulate objects with their own data. Now, that doesn't mean I don't use functional programming. I do because, again, Lua is a functional language. But if you want to go with a more functional approach, go ahead. If you want to go with a more object-oriented approach, you can do that as well. And if you want to use both paradigms interchangeably, then you can also do that. It doesn't really matter to me. Other than that, thank you for watching, and I'll see you next time.